Uh, Carboxylic acid and esters. And esters. No, carboxylic acid and esters, they have the same general formula like CnH2nO. Carboxylic acid has the functional group like C double bond O OH. But if you remove this hydrogen, you will get the functional group of ester C double bond O O. So in ester, the carbon is extended on either side, on the right hand side as well as on the left hand side. But in the carboxylic acid, you can extend the carbon only on one side, only on the left hand side, because you cannot attach more carbon with this hydrogen. Now, the carboxylic acid is ending code is oic acid or anoic acid, and the ester is NO8. Okay, these are the ending codes of carboxylic acid and NO8. So carboxylic acid, it may be methanoic acid, ethanoic acid, propanoic acid, and like esters may be having the different names. Just look at the molecular formula C4H8O2. So if you have the molecular formula C4H8O2, and if you want to draw the structure, different possible structures of C4H02, it means that you are being asked to draw the isomers. So C4H8O2, CnH2nO2. And you know that this general formula represents both the carboxylic acid and esters. So either you are going to draw the carboxylic acid or esters, COO. Okay. Now, if I draw the carboxylic acid having four carbon atom, like C double bond OH is the carboxylic acid, so you can add three more carbon on the left hand side. So this is CH3, this is CH2. Now count all the, sorry, this is CH2 and this is CH3. So one, two, three, four. So you have four carbon atoms on the left hand side, including this one. So this is the first structure. Okay, so this is the first structure. If you want to draw another structure of this carboxylic acid by having C4 and H8O2, keep this area same. Okay, so don't change this area because you can't attach the more carbon on with this area. So if you make it same like this, and there are four carbon atoms, so you can make a branch. You can attach the carbon atom with the terminal carbon because if you attach with the terminal carbon, you will get the same structure. So you can add the carbon with this carbon. So if you attach with this carbon, you will get this type of structure. So these two structures are different, although they have the same molecular formula, but they have the different structural formula. So that's why they are isomer. So these are the two different forms of carboxylic acid. Now you can also draw some esters as well by having the same molecular formula. So esters can be start like that, C double bond OO. You can extend on this side or on this side. You can extend the carbon atom on both sides. So if I add hydrogen on this side, okay, and then there are four carbon atoms, so one is already there. So you can add three more in CH3, CH2, CH2. This is another form of C4H8O2, which is ester, which is not carboxylic acid. Now keep on changing the position of carbon. Mean if you add one carbon here and two carbon here, four carbon are there. Then if you add one carbon here and two carbon here, so you can make another structure. Okay, so this is CH3, this is CH2, CH3, this is CH3, CH2, and then CH3. So all these compounds, or the different organic compounds, they have the same molecular formula, C4H8O2, but they have the different structural formula. They have the different structural formula. And if we go for the nomenclature or naming these organic compounds, this is butanoic acid. And the, the second carbon, there is a branch. So this is 2-methyl propanoic acid. Okay. And this is ester. So the name of the ester starts from here. The length which is attached with the oxygen, single bonded oxygen, that is from alcohol, and this part is from carboxylic acid. So you can see this is propyl, and this part contains one carbon. So this is propyl methanoate. Again, look at the carbon atom. How many carbon atoms are attached with the single bonded oxygen? Two. So this is ethyl ethanoate. Now, here you have the one carbon, so this is methyl, and you have the three carbon with which come from the carboxylic acid, so methyl propanoate. Students, just have a recap which you have learned in the today's class. Uh, Isomers, we're talking about the isomers, okay? Butane, pentane, hexane, butene, butanol, and you have a butanoic acid or ester as well. Now, this is a recap. Now look at the possible isomers. Butane has just two isomers, butane and 2-methylpropane. Just think about these two and try to draw the structures. Pentane has pentane, 2-methylbutane, 2,2-dimethylpropane. Okay, just think about these names and try to draw the structures. Hexane has hexane, 2-methylpentane, 3-methylpentane, 2,3-dimethylbutane, and 2,2-dimethylbutane. Then butene, change the position of double bond or change the length of carbon chain. But1ene, but2ene, 2-methylpropanene. Then butanol, it may be butane-1-ol. If you put the OH on the second carbon, butane-2-ol. If you keep the OH on the first carbon and change the length of the carbon chain, 2-methylpropane-1-ol. And if you change the position as well as the length of the carbon chain, then 2-methylpropane-2-ol. So C4H8O2, it may be a carboxylic acid and ester. So try to draw the possible structures of C4H8O2 in the terms of carboxylic acid and esters. I hope in today's session you have learned a lot. Thank you.